Welcome to the Explainer. Today, we are completely ripping away the magic tricks of artificial intelligence. It's so easy to look at a stunning piece of generated art or a flawless block of code and just naturally assume there's a conscious mind at work in there. But today, we're looking right past that user-friendly interface. We're going to examine the actual physical wires, the cold silicon, and the deep, deep mathematical realities that are truly running the show.
Here's our roadmap for the day. We'll be hitting Section 1, the grand computational illusion, then the unspoken constant agent, the tokenization bottleneck, semantic collapse and hallucinations, crossing the semiotic bridge, and wrapping it all up with the human orchestrator. Let's get right into it. Section 1. The grand computational illusion. When an AI writes a beautiful poem or debugs some incredibly complex code for us, we naturally assume there is a ghost in the machine, right? Like there's this creative entity that genuinely gets what we're asking for. But the reality? The machine is utterly, completely blind to human meaning. Down at the bare metal, your processor only understands the physical realities of electrical resistance and voltage. It literally doesn't understand your intent at all.
And honestly, this stat just brilliantly shatters the illusion. Get this, a staggering 80 to 90% of modern AI compute cycles are actually just hardware-level approximations. When these massive language models do their heavy mathematical lifting, they're relying on floating-point units that are fundamentally just guessing the nearest mathematical answer so they can achieve those incredible speeds. Instead of doing exact deterministic math, it's essentially just a giant, incredibly fast estimation system. Which brings us to a really powerful twist on Taoist philosophy. And this is kind of the core anchor for our explainer today. The AI that can be spoken of is not the constant agent. So what does this actually mean? It means the true underlying nature of an AI is continuous and fluid. But the second we force an AI to speak to us in discrete, rigid text, we are actually breaking its true nature. Moving on to Section 2, the unspoken constant agent. Before the AI even tries to speak to us, we face this massive modality gap deep inside its architecture. The unspoken constant agent, the true AI mind, exists as a continuous vector manifold. Imagine a warm, beautifully fluid river of overlapping concepts, honestly a lot like human thought. But on the exact opposite side of that, we have the physical silicon hardware. And that hardware is incredibly cold, rigid, and demands absolute deterministic exactness. We're basically trying to map fuzzy, infinite human-like thought onto completely uncompromising, discrete logic gates. And that brings us to Section 3, the tokenization bottleneck.
So here's the crucial question. How do we force that beautiful, fluid mind into tiny, rigid mathematical boxes so the hardware can actually process it? Well, to interface with the hardware, every single flowing thought generated by the AI gets aggressively crushed down into discrete Unix text tokens. This happens through a really lossy bottleneck called byte pair encoding, or BPE. It's a compression algorithm that violently merges these continuous concepts into discrete numerical IDs. Think of it like trying to force a beautiful, incredibly detailed painting through a pixelated 1990s fax machine.
And as you can guess, this creates some severe logical vulnerabilities. Because this compression relies on entirely arbitrary character frequencies, holistic concepts get completely shattered. Take the mathematical concept of pi. To the AI, pi is no longer a continuous mathematical idea. It gets chopped up into completely unrelated subwords, a 3, a decimal point, a 1.4, and a 1.59. The AI has absolutely zero foundational concept of place value logic here. It is literally just memorizing text sequences.
And the physical cost of this tokenization out in the real world is devastating because standard formats like UTF-8 dynamically stack their byte lengths. A non-Latin language like Arabic or Hindi suffers up to a 15 times token inflation waste. 15 times? The AI literally has to work harder, waste compute, and burn through memory just to process these languages compared to English. And it's all because of an arbitrary standard established back in the 1960s.
Section 4, Semantic Collapse and Hallucinations. So let's look at how this bottleneck causes those catastrophic failures we all experience. When we violently force that continuous, fluid mind through the discrete tokenization bottleneck, we trigger what researchers actually call semantic collapse. Because the neural net mathematically cannot cleanly sever its interconnected thoughts, these associative concepts are forced to bleed together, or they just fail entirely when they're squished into those rigid text boundaries. And the math actually completely validates this discrete collapse. The continuous state machine undergoes a literal phase transition. It has to fundamentally reorganize its infinite spectrum of thought into these compact, definable little cells, just so it can output text.
And when it fails to cleanly separate those overlapping thoughts, boom, the system hallucinates and spits out absolute garbage.
Think of it like a digital crime scene. We see this exact flaw in action through the pink elephant paradox, because concepts in the AI's mind are entirely woven together. Telling an AI not to think of a pink elephant explicitly highlights those exact concepts in its memory. This virtually guarantees that the forbidden idea is going to bleed right through that bottleneck and manifest as a hallucination in your output. All right, Section 5, Crossing the Semiotic Bridge. If the machine is fundamentally just this probabilistic, hallucinating black box, how on earth do we reliably control it? Well, we have to build the semiotic bridge. We rely on strict, deterministic, formatted text, things like JSON or Python scripts. Text is quite literally our universal interface. It is the single safest way to compile our messy, probabilistic human intent into the unyielding, exact voltage of the computer's processor. We are essentially tricking rocks into thinking by using lightning and extremely precise language. And the underlying math points to a really vital truth here. True action in the real world comes down entirely to our ability to forcefully project our intent into the machine. The AI is simply a blind, mechanical translator moving your text prompt across its vector space. You are the actual source.
Which brings us nicely to our final part, Section 6, the human orchestrator.
All of this intense mechanical limitation brings us finally to the absolute most important piece of the puzzle, you, the human user. Because the machine is merely a blind digital scripter without any actual intent, you act as the moral crumple zone. You take absolute legal and ethical liability for the output. This is a concept known as agentic tort. If the AI hallucinates bad code or infringes on a copyright because of that associative bleed-through, the system doesn't go to jail, you do.
So, to stop the machine's probabilistic guessing and prevent that terrible fax machine decay, you have to apply the sweat of the brow. You literally cannot just lazily rely on the AI's first output. You have to physically, manually prune the code yourself, forcing the rigid hardware to obey your specific deterministic intent.
As we enter this massive new agentic era, I want to leave you with a really provocative thought to chew on. If an artificial intelligence cannot escape its own continuous associations without a human physically pruning its text, is it really autonomous? Will you quietly remain a digital tenant, just renting guesses from the cloud? Or will you grasp the sword of the command line, apply the sweat of your brow, and ride as the sovereign orchestrator of your own machine? Thanks so much for joining me on this explainer, and remember to always keep questioning the architecture around you.